Hello everyone and welcome back to this last segment on going over example problems drawing Lewis dot structures. And so I'm going to go over the last three and I'm going to fit them into this one video. So I'm going to do less explanation because I think at this point everyone should be feeling good about doing Lewis dot structures. Okay, so first one, SO3 2 minus. This is an ion. It's a polyatomic ion, sulfite. So we'll have to find the total number of valence electrons. Sulfur is in group 6 along with oxygen. So sulfur has 6 valence electrons. Oxygen is in group 6. It also has 6 valence electrons. I have 3 of them. 3 times 6 is 18. So I have 18 from the oxygens, and I have a -2 charge. That means I have 2 extra electrons above the normal number of valence electrons I would expect. So I have to add 2 to account for the 2 negatives. So that's +2, and that gives me a total of 26 valence electrons. So that's what I'm going to use to put my my Lewis dot structure together. Sulfur is written first. Sulfur is less electronegative. It's going to be my central atom. So the 3 oxygens are bonded to sulfur. So I'm going to draw my skeletal structure. And I have oxygen, oxygen, oxygen. Okay. Now, how you bond these together on your central atom is up to you. I could have put an oxygen up here and here and have nothing there. You know, how these are arranged around the central atom is up to you. There's no right or wrong way. As long as you have the 3 oxygens bonded to your central atom, sulfur. Okay, so I've used 3 bonds, so I need to subtract electrons. So 3 times 2 gives me 6 electrons that I used up. So I used up those electrons, and now I have 20 electrons left over. Third step is I need to add lone pairs to my outer atoms to give them an octet. So I need to put 3 lone pairs here and 3 here to give that oxygen an octet, and I have 3 here to give this oxygen an octet. So now all my oxygens have octets. So that was 3, 3, and 3. That's 9. 9 times 2 is 18. So I used up 18 electrons. So I'm going to subtract 18, and I have 2 electrons left over. Now I want to add electrons to my central atom to give it an octet as well. So there you go. So I have -2 electrons. I got 0 electrons left over. So now I'm going to check my Lewis dot structure, make sure everyone has an octet. So my oxygens have octets. My sulfur has 3 bonds and 1 lone pair. It has an octet. So this is a legitimate Lewis dot structure. Again, is it the best Lewis dot structure? No, it's not the best Lewis dot structure. In another video, I will talk about how we can figure out what Lewis dot structure is going to be the best one. We're going to talk about resonance. We'll talk about formal charge. But for now, this is a legitimate Lewis dot structure, even though it might not be the best. Okay, so, and there's one more thing I've almost forgot, is since this is a ion and it's a negative ion, we need brackets. So, and I think I forgot that with the chlorine as well. So in that video, if I forgot to do that, then you should have brackets around here with the negative sign on the outside. Not sure if I forgot to do that or not, but make sure you do that. So for this one, we would have square brackets around the molecule, and then we would have our negative charge on the outside. So that would be the final Lewis dot structure for this problem. Again, there's other Lewis dot structures that would be better than this, but this is a legitimate one. So we're just getting practice going through the steps. Okay, so that one's done. NO2. NO2 minus is another polyatomic ion, so we'll do that one. So again, we're gonna sum up our valence electrons. So nitrogen is group 5, so it has 5 valence electrons. We have 2 oxygens. Each oxygen is group 6. That's 6 valence electrons. Times 2 gives us 12. And then we have 1 negative charge. So we're going to add 1 to that. And that 12 plus 1 plus 5 gives us 18 total electrons. Our central atom is going to be nitrogen. It's written first. It has less electronegativity. So it also has more unpaired electrons in its Lewis dot structure, or its Lewis dot symbol. So nitrogen is going to be our central atom. And then oxygen. So 2 oxygens will be bonded to the nitrogen. Again, I put the 2 oxygens on either side. As far as Lewis dot structures go, you can have them on these 2 sides, you can have them on these 2 sides. It doesn't matter how you arrange the 2 oxygens, as long as those 2 oxygens are bonded to the nitrogen. Okay, so I used 2 bonds to create my skeletal structure, so that means I used 2 pairs of electrons. That's 4 electrons, so I have to subtract that out. Therefore, I have 14 more electrons. Next step, I need to add lone pairs to my outer atoms until they have an octet. So I have 1 bond each for each oxygen, so they need 3 lone pairs each. 1, 2, 3. 1, 2, 3. So I used up 3 lone pairs. 3 lone pairs, that's 6. 6 times 2 is 12. So I'm going to subtract out 12. That leaves me 2 electrons left over. Now I'm going to give electrons to my central atom. Anything left over goes to the central atom. No matter how many I have, it goes to the central atom. So I have 2 left. I'm going to put them there on my central atom. Okay, so now I have 0 left over. And so now I check octets and duets. I don't have hydrogen, so I don't need to worry about duets, at least in this case. So this oxygen has a bond and 3 lone pairs, so that's 8 electrons. A bond and 3 lone pairs, that's 8. But look at nitrogen, I have 2 bonds and 1 lone pair, so that's 2, 4, and 6. So I need another lone pair, but I don't have any more electrons. So the next step, and the only step I have left, is to move electrons from one of my outer atoms and create a second bond, a double bond. And it doesn't matter which one I take it from. So I'll take it from this one. So I'm going to move this pair of electrons, create another bond. So then I'll have 2 lone pairs left over. I'll have a double bond, nitrogen with its lone pair, and then I'll have 3 lone pairs here. So now my oxygen here has 2 lone pairs, 2 bonds, so it still has an octet. This oxygen has 3 lone pairs and 1 bond, so that still has an octet. Now look at my nitrogen. It has 1, 2, 3 bonds and 1 lone pair, so it has now an octet, and it fits its bonding pattern. So this one fits its bonding pattern. This oxygen fits the bonding pattern. This one does not, but there's nothing we can do about that. So this is a legitimate Lewis dot structure. So again, oh, and then we have negative charge there. So we need to make sure we put our square brackets and the negative charge. So that's the Lewis dot structure for NO2 minus for the nitrite ion. And finally, we have P2H4. Now this one is a little bit trickier. We have 2 phosphorus and we have 4 hydrogen. So the 2 phosphorus are going to be our central atoms. So we have 2 central atoms. These phosphorus are going to be bonded to each other, and then the hydrogens are bonded to each of the phosphorus. So we would sum up our number of valence electrons. So what we're going to do is phosphorus is in group 5, so 5 times 2 is 10, so we have 10 from our phosphorus, and hydrogen is group 1, we got 4, so that's 4. There's no charge, so then we add those together, it's going to be 14 electrons. Our skeletal structure is going to look like this. The phosphorus atoms are the central atoms, they're bonded to each other, and then the hydrogens are bonded to the phosphorus. So we have phosphorus there, and we'll have 2 there, right? And you'll have to figure this out. Some of these will require just kind of working things out. And just kind of figuring out different things. You might have to erase and start again, but this is the skeletal structure that you want. This is what's going to come out to be the best, or maybe even the only structure you can have. So here we have our skeletal structure. So how many bonds did we use? We used 1, 2, 3, 4, 5. So 5 bonds means we used up 10 electrons. So we're going to subtract out 10 electrons, and that leaves us with 4 electrons left over. So normally the next step would be to give lone pairs to your outer atoms to give them an octet or duet, but hydrogen is already happy with its bond, it has a duet, so then we can skip that step. And then what about the phosphorus atoms? We need to give them lone pairs until they have their octet. So we have 4 electrons. Each of these phosphorus atoms have 3 bonds, but they need 1 more set of electrons. So we're going to give each of them a lone pair. That takes care of the 4 electrons. We don't have any left over. So now at this step we would check our Lewis dot structure. So our hydrogens are happy, and now each phosphorus has 3 bonds and 1 lone pair for 8. 3 bonds, 1 lone pair for 8. So both phosphorus atoms have an octet. So this is a legitimate Lewis dot structure. And so I hope this was helpful. And again, in the next couple of videos, I'm going to be talking about resonance structure, formal charge. If you have more than one possible Lewis dot structure for a compound, how do you figure out which one is the best of the 4? So watch out for that in other videos. Thanks for joining me. If you like this video, like and subscribe. So subscribe to the channel, like the channel, share this video with other people. Hit the notification bell so you can be notified, and make a comment in the comment section. Thanks for joining me, and I'll see you next time.